How's it going, you guys?
Right.
Dan and I are giving you guys a volcano update today. Something
Yeah.
a little bit briefer, but we're going to cover some interesting changes happening.
Right. We'll be going over Mauna Loa and Kilauea and just kind of the data streams and a little quick look at the lake in Halema'uma'u that's been accumulating. But yeah.
All right, so yeah, we'll start off with Mauna Loa.
Right. We'll dive right into that one.
Mauna Loa being the higher alert volcano at this point, given by the USGS at a status of yellow, right? Being weekly updates being put out, but the bottom line is not a whole lot of change there. Still some earthquakes happening under the summit. They've put in some new monitoring equipment up there, and some of the signals have a little bit of scatter, but there's really nothing happening in a volcano that's unusual, different from before, which is that it's still filling with magma and building towards an eruption sometime in a future unknown from now.
Right. So we do have a little bit of, we're looking at some of the data here. We have this little blip and tilt at Mauna Loa. We usually, that tilt at Mauna Loa, it's so early and the magma's so deep that we're not really looking at tilt in this situation.
Yeah, so these signals are kind of the background of what you might see without magma having a big influence. Maybe it has a small influence, but you mostly
Right.
see the day and night cycles. You see some kind of other adjustment. It's hard to say that that's directly magma.
Right. And then down here we get into the GPS stations, and we can see this little change. Let me get the pin out. But we have a little change in what looks like a trend, but oh my god, I can't get the pin.
There it is. Oh, come on, Mr. Madden.
Okay, maybe we don't have the pin.
Yeah, on the right side of the graph there, kind of right in the middle, yeah, there's like a little bit of a gap, an area where it looks a little flatter. And that's the area that, if you notice, there's a couple points above it, kind of some scatter going up, kind of at the beginning and the end of that span. So we know that was, something prompted them to go and upgrade and repair those instruments. And so that kind of whole area in there is a little bit suspect, and maybe it's just something that we can kind of average out without taking too much from it, because there's a little uncertainty there.
Right. So really nothing's changed on Mauna Loa in the last since our last update 2 weeks ago.
That's right, yeah.
Long-term trends are still holding.
Right, yeah, the report mentioned 40 earthquakes in the past week, so we can maybe look at the monthly plot of earthquakes and show you guys that there's been a slight drop in earthquakes. It's still kind of elevated, it's still building and filling with magma, but it's not happening super fast to a point where anything is imminently going to erupt. Right. And Mauna Loa, just to remind you guys, has a fairly large number of precursor signals, including earthquakes and one of the fault systems that surrounds it, as well as sensors of temperature and gas and earthquakes and all that kind of stuff. So nothing happening right now to worry about in Mauna Loa. The more interesting signal is, in fact, in the last month, probably been on Kilauea. In fact, not that it's also not really showing any signs of any change eruptive wise, but the signals are showing that the volcano is alive, and there's some interesting changes from before that maybe we can discuss and talk about what they possibly might mean.
Right. So yeah, just sum up Mauna Loa. We can still see the elevated seismic rate since late 2018,
Mm-hmm.
and they just kind of come up like that. Let me get a better color.
We got the pin working. There it is.
Bam. But
Right.
we have this little spike, and right now it's still elevated. Basically,
Right.
there's little fluctuations that happen month to month.
Right.
But overall, this is just an upward trend in there. All right, let me get rid of all those doodles.
It's gone down a couple months in a row, but we can expect it to go back up again, and to kind of similar levels, and that's okay. And unless it's really going into the thousands, then it's not the ramp up we're looking for.
Right. All right. Let's transition to Kilauea.
Yeah, I did it a little early, but so
Yeah.
the Kilauea information. There's kind of two areas to look at. One is a summit, and one is a rift zone. Maybe the first thing to look at is our GPS plots, perhaps.
Yeah. Let's pull those up.
So this is a USGS deformation webpage, right? And so we're going to scroll down here to the GPS section below the first tilt plots, and we can look at there's these top two plots. The very top one is the one at the summit showing the distance across the caldera, right? So and now at the very top is the past year. Just below that's the past 5 years.
Right.
And we've talked about how there are two different factors influencing the movement of this distance. One being the most obvious, magma coming into the volcano, but also the south flank moving, especially the south wall of caldera moving to the south as a response to the south flank. So, it's possible that we actually see two different linear trends. If you want to draw them on there, Dan, like the first half of the graph up here showing a flatter line, and then the second half, a little bit of a steeper line beyond that, right? So kind of, yeah, 2 changes right in there, and kind of, so it's kind of sped up, and you might postulate that the period beforehand might have been more of the background of the adjustment, the flank moving, and since then we have the added effect of magma actually causing a faster rate of spreading at the summit. And according to USGS reports, this is corroborated by the INSAR data. There is still no signs of shallowing and no gas changes at the summit, especially as regards to the magmatic gases that might come out.
Right.
There's still plenty of steam. There is still water filling in the crater at the summit. We'll talk about that in a little more detail later.
Right. One interesting little thing you'll see here is this little guy.
Yeah.
Right in there. So
on the rift zone.
On the rift zone at Pu'u'o, crossing over the rift, the distance between basically the north side of the rift and the south side of the rift at Pu'u'o. Right. That's what this is measuring, and we have a little blip right there. Now,
yeah,
we can talk about this a little more. One of the interesting things is we've actually seen this before, this type of a blip.
We have.
On a station that was also at Pu'u'o. It was just danger close to Pu'u'o and kind of fell into the crater post-eruption as everything continued to move.
Right.
So, and it was for a while we knew that the station was compromised and the signals that it was giving out were questionable at best. I mean, yes, it's actually moving, but why is it moving? Is this magma related, or is this just the cone settling post-eruption?
Right, and both are still possibilities, but given that the last thing we saw was a settling event, it's that should be our first go-to option this time, especially considering the signals are the same and lacking gas that shows any new young magma coming into the area.
Right.
And we know the south flank is still moving. It's actually been noted in every report recently, so it's quite possible that that's actually what's happening. So we've actually done a little bit of a survey looking at all the different GPS stations, across the volcano, and mostly this effect is constrained to the area near Pu'u'o. And you don't really see it even as close as Makapui to the west or Jonica to the east as much. There are some little changes happening, but nothing that's really showing that steep signal that we just pointed out to you guys in the last plot.
Right. And you can see the rift zone here, and we're working our way across it between this station and this station. That's what that plot is showing.
That's right, yeah.
The distance between those.
In pinkish to red, that's the rift zone, you guys. Kind of that band across the middle of the screen right there.
Right.
And
so, yeah.
all those stations are inside of it.
Right. All those stations are inside of it, which is a very volatile area, very questionable. Like, one of the hard parts about this is we don't have stations immediately down for obvious reasons, but, basically it would have been covered for the past few decades, but it would be interesting to have at this point in time.
Absolutely. I mean, our whole monitoring network was set up in the area of Pu'u'o to monitor magma moving through the system, and for that kind of result, these stations are perfectly placed.
Right.
But if you're really trying to monitor the movement of the south flank, you'd like more stations on the south flank and not in a rift zone. That's kind of the in-between transitional period from the stable part of the island that's still remaining and moving a different direction from the south flank.
Right. And we can show that basically the flank has been moving since the magnitude 6. Well, it's been moving for a very long time.
Yeah.
But since the magnitude 6.9 quake, it went into an elevated rate of movement faster than it was moving before. And since the eruptions, and a year plus, a year and a half almost, that rate really hasn't slowed.
Yeah, maybe we can zoom out and show where the Kalapana trail station is, and maybe we can look at that plot, because that one is the one that's shown us the quickest movement of the south flank from what it was doing before the eruption, right? So let's show you guys that plot right there, right? So, we've shown you guys this before, but just kind of reiterate, this is the one that's the most obvious. The big drop right in the middle, center left of the page across all 3 components, that's the actual April 30th earthquake movement adjustment, and then a big 6.9 on May 4th, right?
Right.
And then you see the next kind of bar, maybe you can kind of draw in there, yeah? Like that kind of...
See the drop.
That's the drop, yeah.
Yeah, and then
that next frame is the bounce back, exactly. And then right at the end of that curve is where the eruption actually ends. That's the 4 months of eruption in the middle where it's kind of bouncing back. And then since then is what I'm interested in, is that line going down is going down steeper at a constant rate than it was
line here.
Exactly. That's exactly right.
Yeah.
And that is the one that shows, if you actually calculate it, it's in an order of 4 times faster And that's just one station. It's kind of in the center near Makapui, but that kind of shows...
It's an important station location-wise for the south flank based on, I mean, here, let me pull that back up. Get rid of this. Back to this. Right, we're off of the rift. We're now on south flank mostly in this type of spot. And there's not many around it. We do have this PG2R station.
Mm-hmm.
But really, this is kind of a one-of-a-kind station for us. A very important station because it's right where the movement from the south flank is almost heaviest. It's right in the middle of this whole movement of the south flank when we talk about it.
Yeah, it's like the transition kind of to the east of there. It's like really the south flank block by the east rift zone, and to the west of there, it's really the south flank block below the summit.
Right.
So there's this kind of a transition area, near the curve in the rift zone. It's all kind of all related. And we won't get too far lost in the weeds there, but I just wanted to point out just that one plot that kind of shows that is continuing unabated, and it kind of keeps being mentioned in the USGS reports as well that are now being put out monthly for Kilauea. So that kind of covers GPS a little bit. We haven't covered every single station, but kind of you can go and look yourselves and see that the signals are really constrained to the area around Pu'o'o, and that's why we kind of suspect, first of all, the first suspect would be collapse locally in the area, or settling, or something along those lines, and if there's a sign of gas detected, which the USGS report for Kilauea came out just a few days ago, and this pattern has been happening for about 10 days, so presumably any changes would have been detected, and nothing came out in the report about any change in the gases, and so I think we have faith that that's the way things stand, and it's likely a structural settling of the area rather than a magmatic adjustment.
Definitely, and you can one of the things that this map does show currently is you can see these little circles with the cross through it, the little canceled sign. Those basically are indicating in this that whatever happened in the past 10 days, this thing that we see at Pu'u'o on the GPS and tilt, we cannot collaborate anywhere else.
Yeah, it's not reflected.
We can't see it in these other stations when we start looking through them.
Yeah, not that they don't have changes, but nothing that's like that's related to that most obvious signal near Pu'u'o.
Right.
Yeah. Yeah, so, given that there have been changes in the last 10 days, that maybe makes the tilt a little bit more relevant because it does detect those shorter term changes. So we could talk about the tilt a little bit, as far as what we might see in that area of the rift zone in the last 10 days and see if anything might have shown up that we don't know. Like we said before, there was no sign of it being magmatic, but it still might have shown up in a tilt, whatever it was that happened as far as an adjustment.
Right. And here we have the seismic for the past month, and we're showing south flank in the same area, basically the seismic activity, and then the summit up here. So let's have the pin. Summit, earthquakes, south flank earthquakes.
Mm-hmm. Yeah, and the south flank earthquakes, you see how they don't go all the way down to Leilani. They kind of stop just east of Pu'u'o.
Right.
So right now, that's the area that's adjusting the most. And beyond that, it doesn't seem to be adjusting, at least with earthquakes, expressing that movement, right? It could be moving more slowly, but it could also not be moving as much either because nothing is wedging in there anymore, right? It's kind of being wedged down by gravity and movement of the south flank.
So Nathan asked, did we notice the swarm of 20 earthquakes at roughly 5 to 7 miles below the summit on 10-1, 10-2 before the uptick? That would be 10 days ago. Yeah, it'd be roughly the same time, though, as that uptick. The uptick, I think we're saying, was at the end of last month.
Yeah, I mean, so we have the earthquakes kind of following similar patterns, right? There is...
Let me pull that up.
There were that series of adjustments. It was hard to say that any of those were definitely a magmatic. I mean, I'm still not convinced that there isn't some adjustment in the sense of settling. I don't want to necessarily use the word collapse, but like collapse-like movement. Same direction kind of thing as it settles and the south flank moves. That's a possibility. The fact that there could be a temporal link, a link in time, might mean that there maybe was a pulse of magma moving through. Right. That's what we really would like to know more and eliminate as a fact that is a possibility that magma might come through the volcano, somehow bypass the summit and poke itself up only at Pu'u'o without showing anywhere in between. And, I can't exclude that, but it doesn't seem like a very strong possibility.
Right.
And not something that I would count on or put money on myself.
And those earthquakes, the 20, they must be small ones because we're filtering by, what was it, 1.5?
1.0, I believe.
1.0.
There's a 1.0.
And, 1.0. Yeah, 1.0. We have a 1.0 right here. We have some, on that day, but they're not that unusual. Like, yeah, that 12 kilometers is a little weird, but it happens. Zero, shallow, sea level happens. These are, and there's just not that much. There's this 2.5, which is kind of interesting. But yeah, it's pretty constant in terms of this is what background kind of looks like on this thing.
Yeah, I mean, there's nothing quite obvious, right? You know, and the other thing to mention is there are Pahala earthquakes happening. Those flurries of deep earthquakes in Pahala still going on, and you know, those are happening kind of more or less at the same time. But the thing that there's such a distance between there that we have a hard time linking them, even if they happen at the same, more or less same time.
Right.
Connecting that to something happening so far removed from the surface and also horizontally away from the location of the earthquakes. It's really hard to tie. You know, I mean, it may be connected. It's been speculated in the past in certain eruptions that there's some connection, and you know, we might debate the delay, but there's people who might say like, well, really, I can't believe any of that.
Right.
Yeah. Definitely. You know, there's really nothing conclusive there. Right,
and it's just really easy to start throwing correlations around on that one, and it's seemingly so random to me that as soon as you start looking for patterns, they're just going to pop out at you everywhere. You're going to see what you want to see too much on that one.
We are pattern-seeing creatures. Like, we see faces in every aspect of nature. Even, for example, you know, we see all kinds of interesting things, and we just got to be careful. That's all. Right. Yeah. So we really can't say anything more about those earthquakes right now, you know, but in future we hope to address this in more detail. So that's kind of earthquake story, kind of showing South Light movement still, you know. Here is our tilt showing for the last month both the summit and the rift zone. The summit's being shown in blue, the rift zone in green. So since we've been talking rift zone first, maybe let's focus on the green line first and then kind of work our way back up. At Pu'o'o, you can see the scale on this graph is kind of, you know, from the beginning left to right, changing about 10 microradians, but you can see that there's a very slow rise with occasional flattening spots in the east rift trend. And it's not quite clear, you know, or right where Dana is with the pen now, it actually maybe gets a little steeper right in there. Yeah, that's kind of the 10-day ago period right in there, right?
Yeah, I don't know what to draw in here.
Towards the end of September, right? Kind of steeper.
Right. Oh, yeah, we'll just ignore that one part of the line.
Yeah, so below it was like what it might have been, and you can see it's a little bit steeper at that last part. It almost kind of forks upwards a little bit, right? So let's call it a little fork there. And maybe that increase is an expression of whatever is changing the GPS as well.
Right.
Whether it's ground settling or ground tilting in the area. That would be
that one weird thing that we were talking about is somewhere around here.
That's where it begins, is around about 10 days
around
ago,
that time.
There, yeah.
All right. So, yeah, the one interesting thing here that we see is all of these DI cycles.
Yeah. On the blue line, which is a summit.
They're just DI.
Big ones, small ones, medium ones. The biggest ones are in order of like 5 microradians. The small ones in an order of half a microradian, perhaps. You know, they kind of stack on each other. There's a lot of them happening. We haven't seen this many on a tilt plot in a while. It's interesting. We really can't say much as far as what it really means, apart from, you know, that we believe there's movement of fluid down within the volcano.
Right. And
which fluid?
And we've talked about before after post 2007, the increase in DI cycles that we saw at the summit, but we're not talking like this type of DI frequencies. This is pretty quick, and a whole bunch of different variations. The one interesting thing is we are still shadowing the DIs on the rift.
Yeah, what he means is that, you know, when the actual summit is going into deflation event, the Pu'o'o East Rift line is not climbing as fast, it's flattening out, and it's happening at about the same time. There's not a whole lot of delay that we can see from these graphs. So not necessarily instant, but pretty close, you know, within the resolution that we can see here. Right. Every time a summit's going down, the rift zone is flattening out. And when a summit's coming out of its DI, then the rift zone starts tilting more.
Definitely. And this is just like one of the trends that the DIs have, kind of like the Pahala earthquakes, kind of come and go in flurries. But this definitely notable.
Yeah, it's an interesting month to look at, and you know, if we kind of see this happening month after month after month, or stop happening month after month after month, we can maybe speak more to it. But it's just one kind of observation within a whole context of different things that we're looking at, right? So she's still alive, she's still breathing down there, is one way of thinking of that, you know. But you know, there are times that we have more, sometimes we have less, and right now we have more. So that's an interesting aspect of the tilt today. And we have, USGS is saying there's no difference in SO2. They're saying that there is really not much difference in INSAR. The INSAR is also showing the same previous conclusion, supporting magma filling within shallower parts of the summit caldera, but not shallow enough that it comes to the surface as gas or makes a threat of eruption.
Right. So yeah, it's pretty much kind of same old on the big picture, right?
The big picture, yeah. The plots are looking different this month, which is why it's a little more exciting to talk about, But as far as the implications, there's really not a whole lot of change. We're still in a recovery phase as humans in the story of eruption, and we're kind of keeping our eye on things and trying to look forward and plan better for the next times. But as far as the signals, that's really not a whole lot of change that's conclusive, apart from maybe that thing at pool, which is suspect. We'll keep an eye on it, but it's too soon. There's no signs of gas, and our best interpretation at this point is that it's likely to be a similar kind of settling as the previous funny signal at pool was as well.
Pretty much. And we have something to go off of up there. We've seen it once, and to think that whole cone is just stable elsewhere, just slightly outside of that one station. It was just that one station was bad. And that one station got compromised, but none of the others around it.
Yeah.
It's a little bit of a bridge too far at this point in time. So let's transition to our crater lake.
Mm-hmm.
Lake Halema'uma'u, or whatever it's going to be called. Still growing, still accumulating. We can see this scale that Hawaii Volcanoes National Park put out. It's a little bigger than that now, but basically the size of a football field. In terms of the lake, now it's more like a football field if you include an end zone and one of the sidelines, maybe two of the sidelines, but it's still in that realm.
And you're saying 10 meters deep, so 30 feet or so?
Right, a little bit over that, and it just continues to a few inches a day basically, in terms of steadily rising. Then the temperature is pretty consistent at about roughly 70 degrees Celsius. Roughly the same temperature as the Keller well, which is one of the deep boreholes that you get some water samples from. So it's again still suspected to be the water table. Still suspected that this is the beginning of a much bigger lake that's going to eventually continue to accumulate until reaching some kind of equilibrium.
Yeah, you said a couple of things that are interesting to me. First, maybe we'll talk about this first. First is you've been calling it a lake, which is fine with me. But, we looked it up a while ago, and, a lake you can't see the bottom of, and a pond can. But what this picture is showing us is a size, maybe something that's important to us as well, the size of this thing filling, essentially a whole stadium. Right. The last time we used a stadium analogy in this location, it was in reference to the size of the Overlook crater, which held a lava lake within it up until May of 2018, right?
Right.
So that was a lava lake. It wasn't a lava pond.
True.
So I am totally on board with calling it now an actual lake within Halema'uma'u.
And it's just like there's other places that are called crater lakes, and they're not that big.
For sure, yeah. And it's murky. We can't see the bottom, so we're just gonna, I'm just telling you guys I flopped. I'm happy to call it a lake from now on because that, especially this graphic really drives home.
It's getting big. It's definitely getting to that point when, some point, it's just going to be. We transitioned from stop calling it a puddle to a pond pretty quickly.
Pond to lake,
to lake.
So the other thing you said was you mentioned the Keller well, and the Keller well is something that's been revisited recently, and maybe you can tell us about what was found when USGS went back there.
Right. So after the eruption, USGS went and sampled Keller well again, and what they found was that it had dropped roughly 10 meters since the eruption took place.
Fall of 2018.
Yeah, fall of 2018 from pre-2018. Which wasn't unusual, really. It fluctuates, and there's a long history of it fluctuating at the water table, the heights in it. But they went and checked it again, and now it's bounced back and overcompensated almost. So it's back up to levels comparable to pre-2018 eruption, which would, if we're doing calculations on the size of the lake, or at least the depth of it. Well, with that, you can just maybe add another 20 feet.
Yeah, it matters.
It matters. Add another 20, 25 feet in depth and to whatever estimate we had, and now it's just a bigger pond.
Yeah,
than
or
what we're
more,
talking-
because
yeah.
I mean that actually may be a wave of water that's moving right underground, flood in a sense, a surge underwater water as it
Right.
equilibrates from a higher to lower spot, right? So
Yeah, we don't know what
it
the
could
water
keep
table's
changing,
gonna
right?
do.
And yeah, it's gonna get deeper than we thought, most likely.
Yeah, it's still going to be a pretty big lake, multiple times larger than Green Lake was. It's new, but like, here's the thing: is when we talk, it's coming up like, oh, it can fill 250 feet. All right, that's like, oh god, that's a huge pen. That's like what, here-ish? No, that's not even there-ish. It's like there-ish.
Yeah, maybe we'll overtop
Maybe over top, something like that.
the seats of the stadium there, right, and put the whole stadium underwater instead of just the field.
Well, it's just, we're talking like, look how much bigger this thing is. There's still all of that distance.
That's right.
This is a huge crater. Like, this thing could fill in over estimates and still not even get close to halfway up this collapse pit.
That's right. That's right. So yeah, it's going to be a long, slow, drawn-out process of watching that thing fill. We showed you guys the time lapse last time, when we save it for another time. And that's kind of the story of the water in there. Is there anything else you want to add about the summit?
Not
Rift
really.
zone?
Basically, everything is in kind of that weird background level where we're still holding, like this holding pattern
Right.
on both volcanoes.
And then
We're still waiting for everything's so nuanced right now that it's easy to look too deep into something
right.
and look for patterns that aren't really there. Really, like, what I'm looking for is big changes, a big jump in gas, a big jump in seismicity, clear indications of something moving. There's so many seeming like false positives, but they're not false positives, but it's like they can be interpreted that way.
Yeah, we got to be real careful with this, right? I mean, we actually saw the signal at pool, showing some change. We're not going to jump to, there's no signal that it's anything beyond what we've seen before, since the end of the eruption. So there's no point to jump beyond that at this point, but it's something that's different from what we saw before. It's different from the background happening in the area, so it's definitely noteworthy, even if it just tells us, hey, by the way, the station's really never been as stable as maybe we thought, which could be the case or could not be the case. We don't know yet.
Right. And the earthquakes on the south flank still expected, still could get up to magnitude 5 point something range potentially.
That's right.
This is like the previous 5 point something that happened. It's still technically going to be considered aftershocks from the 6.9.
That's right. We've been talking about the 1840 eruption as a kind of analog, and in 1840 we talked about how there were three earthquakes of magnitude 5.5 or larger in the following 3 years or so.
Right.
So we've had one of those. We might expect one or two more possibly. Maybe not immediately, but it's not out of the question.
Yep, definitely not out of the question. But yeah, I think that's basically wraps it up. See if we have any final questions.
Yeah, coming up next week, I believe the U.S. is having the Great Shakeout, right, and doing some earthquake preparedness outreach, so you guys can check that out. We'll maybe cover that in the future after it happens. We'll leave it at that for now, but keep your eye out for that.
Definitely. And we'll be having some more content come out in the next few days. Tomorrow, I'm going to be interviewing Travis Sanders. We're going to be sitting down and doing a little bit going back through some of the footage and reliving some of his experiences during the eruption. And he has some of the most unique footage that I've seen. So yeah, we're going to try and do that and do it right. We've been actually sitting on that footage for a year to give people time to heal and stuff, because that footage is that heavy. Even with editing to clean it up and make it soften the blow, it's still heavy.
It's still, it's a tough thing, but it's part of the healing process for all of us to kind of come to face with what we went through and what we all survived, and
definitely.
It's maybe it's not never easy, but it's maybe a little easier now than before possibly, and if it isn't, that means we have something that we gotta address internally, and that's a good thing, and you don't have to watch, of course. No one has to watch if it's too much at this point.
Right. And that's about it. Well, thank you guys.
Yeah.
Definitely. And until next time,
stay classy, Puna. Aloha.